What we do is introductions and then start recording after the introductions.
Oh, well, we've started here.
Well, that's just fine.
Yeah, we can let it go.
So I will share my screen. And here we are. So good morning, everyone. This is Michael Uschold from Semantic Arts, and we're going to do part 2 of an overall introduction to GIST, which is an upper enterprise ontology. Why do we have GIST? Punchline is we're going to build better ontologies faster. So I'm going to do a quick review. We had a whole session a month ago, and we often do this, but we're going to skip over that today. So we have our recording already going. So quick outline of this overall presentation. I'm going to kind of quickly introduce what GIST is about, what its design goals were, and really the bulk of it is to go through each of the main type subject areas, different scope for the main concepts and main relationships. And in doing so, we'll introduce some of the patterns that we commonly use. If you are using GIST, make sure you use its copyright. It's a Creative Commons Attribute Share Alike license, and this is where the current version is. We're on 11.0.0. Okay, so what was the purpose? What is the purpose of this broad introduction? We really want the attendees to understand the background purpose and uses of GIST, right? To have a good idea of kind of the broad overall structure, some of the key classes and key properties that we use day to day in building ontologies based on GIST. And the stretch goal, if you like, is once you have seen this presentation and maybe done some poking around after on your own, you'll be able to begin the process of mapping existing ontologies to GIST if you need to do that, or maybe create your own ontologies based on GIST. And then to, just enough to be able to go ahead and explore further and understand GIST on your own. It's easily downloaded from our website. Okay, so what's the scope of GIST? So there's persons, organizations, physical things, places, events, time, variety of different things, addresses, products, templates, content, a whole bunch of stuff. And what's in green here is what we went through in a fair amount of detail last time, and I'm just going to pick up from where we left off. Not everything is in the exact order of the presentation here, but it's a little bit close enough. All right, so we're going to, I'll just briefly outline what we have with persons and organizations and whatnot. So the two main important classes are, entities that can do something. A person can do something, an organization can do something. And so we have a variety of things. You can think of that more broadly as a party, which could be an organization or a person. We also have physical things and substances, like a building is a physical thing, a laptop, but an idea is not, and an agreement is not a physical thing. And I have a variety of classes and properties relating to places and events. So now I'm going to talk about time. So we had an original model that we used for many years, 5-10 years, ever since I joined Semantic Arts over 10 years ago. And we just changed it up. So I'm going to for those of you who have used GIST in the past and may not have upgraded to the most recent version, I'm going to describe that change a little bit. So what we had originally was a main class called time instant. And if you want to say something happened or is going to happen at a certain time, you would have a time instant as the object of a given triple. So let's say an event would have an actual end date, or a person would have a death date. That's a subproperty of actual end, or something, a conference maybe, or a talk. For example, this talk started at 11 o'clock Eastern Standard Time. Sorry, Eastern Time, Eastern Summer Time, actually. Or maybe when was something recorded, and all these things have a range, if you like. The value at the end of the triple is going to be a time instant, so just a moment in time along a timeline. Now, what we had done is modeled this notion of a time instant to have a precision. So it might have a precision of a microsecond, which would kind of be what a computer would care about. When did this transaction occur? If you're on Wall Street, you probably care about nanoseconds. If anybody read the book Flash Boys. And then things that have not occurred yet, but you plan them. So an event is going to happen in next month or next year. A conference plan is planned out years in advance sometimes. So we have planned times, modified times, recorded times, all kinds of things like that. So what we did was we changed things up. Instead of having a class called time instant, we have, and the precision information is on the time instant. Instead, we have a handful of data type properties for the most common lengths of time that people care about. So a date is kind of like a 24-hour range, a minute, or a microsecond. So how does that look at the moment? So this is the current model for properties and gist. So there's two main things. There's end date, things that end, and things at time, and there's also planned start time and planned end time. But we have variations of this. So there's something happens at a time, and then there's different subproperties of that. So it can happen at an end time, or it could happen at a start time, right? So then if the actual end, if you care about the microsecond or the minute or the year, then you pick the one you care about. So that's how time works. Okay, moving right along. Again, this is a quick overview. We're not going to go into anything in glorious detail. So what's a commitment? Well, we have a broad category called intention, which is kind of specifying what you want, what things should or shouldn't or must not be. And one example of what you intend to be going on is a commitment. So you make a commitment. What is it? Take one example, an agreement, for example. You take out a mortgage. So here's the definition of a commitment. What is it? It's a commitment. Sorry, an agreement is a commitment. It's a commitment with the following situation going on. It has at least one party. No, in fact, it has at least one party, but really it has two parties, an agreement. And it has two obligations. So in the case of a loan contract, you have an obligation to fund the loan on one party, and the other party has an obligation to make loan payments. Another example of an agreement is an account. People don't often think of an account as an agreement, but actually there's always an agreement underlying, like your bank balance or even your mileage account with United Airlines. Say that you have 272,000 miles if you fly a lot. That's an account. It has a balance, and it's an agreement. There's a legal agreement, what that all means, and it's tracked by United Airlines. Now, it turns out that the royal we, which is to say David Bacombe, has been working on, in conjunction with a couple others, a whole separate account ontology for GIST, so we may describe that at some point. And it's all based on this notion of an account being in agreement with the balance. Now, another really important thing is offers. Let's talk about offers. There's something that is on offer, right? So we talk about a catalog item. That's the thing you're going to sell. So I'll sell you a brand new iPhone 14 Pro Max with, X amount of storage and that color or whatever. So that's the thing that's on offer. So we call that a catalog item. Who's offering it? Well, we have a property called HasGiver. It's the one who's providing something. And so who's offering the thing? Either an organization or a person. It's for a certain amount of money. And here's the new time properties. The offer is valid for a certain time. So it has a planned start date. This is not the sensible order because it's alphabetized. Actually, that's not even, yeah, it is right. It is true. E comes before S. So it has a start time of some RDFS literal. Now this is because there's a variety of different ways you can express time. That's why it's RDFS literal. Now for those of you who are familiar with using the other form of time instant, everything is the same on this second one here, which is the prior way of doing modeling time. Instead of saying planned end time, exactly one RDFS literal, and planned start time and start date time, we simply have planned end pointing to a time instant or has start pointing to a time instant. So that's how things have changed. So let's talk about catalog items. What is a catalog item? Trivially, It's something you could find in the catalog where you're looking for something to buy. Let's look it up in the catalog. Those of you who are old enough might remember Sears catalogs, the original mail order. Everybody goes to Amazon now, but it used to be mail order catalogs. And what's that? In there is just a list of things that you can buy. So, for example, you can buy the iPhone SE 2020 color red with 128 gig of memory. If you're somebody like me, that's what I did one day. So there's the catalog item itself, which is the actual thing you can buy, and you could put it on as a line item on an invoice, and you could pay a specific amount of money for it. But then there's the product category, and it just has a class called category. We'll get into that a little bit later. And product category is a really important one. So iPhone 13 is really a product category. You can't walk into a store, an Apple store, and say, please give me an iPhone 13. How much does it cost? They're going to look at you. It's like, what do you mean? Which one? So that's really a category. In fact, the iPhone 12 is a category. iPhone 8 is a category. And then those at the higher level categories, you have a category hierarchy, really. So iPhone would be the top of that chain. And then even further up from there, you have smartphones. That's another category. Now you get into classifying industries. There's a smartphone industry, right? And then if you go up higher, there's electronic device. It's another category. So sometimes you need to model these categories. We've done a lot of that work with some of our clients. So the point
Michael,
here
you got
is,
a question? You got a hand up if that's all
yeah,
right?
go ahead.
Yep.
Whoever that is.
Mr. Sullivan.
Yeah, where does barter fit into all this? Because it gets deeper than that, because I mean you got things like Tinder, right? And you swipe left and you swipe right. The intention is I'm interested in you, but there's, so there's all sorts of things that are non-product oriented. I'm just curious how you imagine this fitting in.
I'm gonna pass on that. I'm gonna give you a fudgy answer, which is to say, in a typical enterprise, which is the focus of just barter, won't happen. And so if it does happen at some level, it won't be recorded in information systems. So the scope of just really is those things that are likely to be recorded in enterprise information systems in a typical enterprise. So
I'm good with that. Thanks.
Yep. Thanks. It's very interesting. Now I might go away and to spend my evening trying to model it, because it seems like a fun idea. But we don't care about that in just. But that's an interesting question. Thank you. Okay. So we mentioned briefly intention earlier on. We had an example of commitments and agreements. So what is it really? It's kind of an abstract class for characterizing how things should or should not be, really, broadly speaking. There's a number of things about number of examples we have. The more interesting subclass is permission. So for example, a license to do something. A physician, a hospital as an organization. We think of a hospital as a building, and there is a building that houses the services that go on there, but technically a hospital is an organization, and it has to have a license, and the license is granted by some other government body, et cetera, et cetera. So that's really a permission to do something. The license to have your car, there's all kinds of permissions out there that are formally recorded. We also have a variety of other things in GIST, which are there, and they have been there for a long time, but they don't, in my experience, don't get a lot of use. Functions, goals. Now, there are a variety of subclasses of requirement, which we'll get into, including specifications and catalog items, which are quite important. And we also have a restriction, which is something that you're supposed to not do. But again, we don't use that very often, and it's unfortunate duplication of the name restriction, which is part of the all language. This is a different restriction. So that's kind of a broad understanding. So intention is really not a kind of thing per se that you can model. It's more a grouping class. Most of the classes in just, really subclasses, and they have a meaning in and of themselves. This is more of a grouping class, things that are quite similar to each other. Okay, moving right along. Content. So content is hugely important in any organization. It used to be physical pieces of paper, up until 20, 30, 50 years ago when computers became dominant. So what kind of things are content? Documents. They're expressed in a language. You know, you can have different media, paper, but these days it could be PDF, or it could be a JPEG, or it could be any number of things. Addresses. We'll get into addresses in a little bit more detail, but address, people think of it as a place, but it's really content. It's really something that points to a place. It's kind of like a route algorithm of a sort. Messages. You know, I send you a text message, or you send me an email. Identifier is another example. What is an identifier really? We'll get into that a little bit more. Your social security number. What is that? Well, it's a number. It's content. Or just plain text is a subclass of content. So we have a bunch of different kinds of content. Let's talk about one example, a content expression. So that we borrowed, there's something called Ferber. I'm not sure what it stands for, but we borrowed some of those concepts. We didn't need the full detail of that, but here's just an example of what's going on with just. So let's say, here's the definition of the class content expression, right, of just itself. So what is content expression? First of all, it's an all class, and it has a definition. It's intellectual property reduced to text, audio, etc. If it contains text, written or spoken, it may be in a language. It will be in a language, I guess. And then it has a preferred label. It has, we always point to the ontology where the concept is defined in case there's different modules and submodules. It's also a subclass of content, so it's a kind of content. And then it's a subclass of two restrictions. So what does this mean? This means it has a language. So any content expression is expressed in, that's this property from just, is expressed in some language. And secondly, it's some kind of media type. So it's categorized. It's in the it's some kind of media type category. It's in some. There's a lot of categories of different types of medias, and it's in one of those categories. So that's how content expressions work. Language. What is a language? The recognized, organized set of symbols and grammar. So this is pretty broad definition. Natural languages such as English, Spanish, Chinese. Computer languages such as, you know, Python or Java or XML or all kinds of different things are languages. It's meant to be inclusive of all that. Okay, another special kind of content is identifiers. So identifiers are quite interesting, and there's a whole hour-long just counsel on this that Dan Carey did in the last year or so. It's actually quite good. Tells a lot of the whole story. It's quite complicated. In fact, we're revisiting some of this at the moment. Identifiers are one of those things that seem like it should be easy and simple, but it turns out there's lots of nuance, and we'll talk about that for a few minutes. So in the real world, any given thing, for example, yourself or an organization may have multiple identifiers for the same thing. So you and me have tax IDs, we have state issued IDs, we have email addresses, and all these things can serve to identify a given individual. So I have more than one ID, and an organization might have stock ticker symbols that identifies the organization, industry IDs, any number of things are possible. Assets, a stock number or universal product code. So that's lots of identifiers all over the place, and any given thing can have more than one identifier. What's interesting is, technically speaking, I mean, a stock ticker symbol for, say, Boeing, I think is BA, but there might be some industry that has that same two-letter thingamajig. So you have to be able to distinguish, well, is the BA a stock ticker symbol or is the BA an industry ID? So you need some kind of way to specify the context for the identifier. And here's a property that for a given context, for different, like for driver's licenses, it has to be the case, you know, that one person has only one driver's license issued by a given state. But the uniqueness goes the other way also. For a given driver's license number, it needs to point back to only one person. So it's kind of like a uniqueness that goes both ways. And if you have a symbol called BA, and it's both a stock ticker symbol and it's an industry ID, you have to have some way to say, oh, this is not just any old random text string BA that I'm identifying, that this is part of some broader context. So you have to have some way of representing that context. So let's have a look at how we do that. We do that with just ID. So what is just ID? First of all, it's content. And the one thing we say about the content, so a driver's license ID is identified by, is allocated, who mints the ID? Who's in charge of saying what the ID is? In the case of a driver's license, it's going to be the state, probably the State Department of Motor Vehicles. In the case of a social security number, it's some part of the federal government. And then here's the punchline. I mean, the actual string, there's still a string. So in other words, the ticker might be BA for stock ticker identifier, but for some other industry categorization, BA would be the same string, but it would be in a different context. It would be minted by a different organization. It would have maybe different rules about it, etc.
Yep.
Okay, great. So in this particular case, so in other words, we have a standard pattern to use, but it doesn't mean it's going to work every time, as Patrick just pointed out. So we have just ID, its content, it's allocated by some organization. And what Patrick just said is sometimes it's not so easy to identify who did the minting, which is different than saying it wasn't minted. So the way OWL works in open world is it says, we know that in fact, some entity, whatever it was, did decide what number or set of text strings to give you. So somebody did that. It was allocated by something or someone, maybe even a computer, which is kind of it goes under the rubric of intellectual property. So just because it's true in the world and you know it was minted somewhere, somehow, some way, it doesn't mean that you know what that is and you're going to put it into your database. That's where shackle comes in. So you could say in my database, I absolutely require to know who that is. In fact, it has to be an organization, whatever your context might be. But in other organizations, for example, in Patrick's situation, you might still use just ID, but not worry about this thing that's true in the world because it's not true. Now the inverse identifying, the inverse functionality is going unique the other way. Actually, let me ask this real quick, Patrick. Is it true that in your situation, a given identifier can genuinely identify more than one different thing?
I don't think that it actually can. It's just that at the level of visibility that we have, which is data given to us by a supplier for their catalog, we have limited visibility into, how they use these identifiers.
Right. Well, we'll have a separate I'll come back to Rebecca on this subtlety because we're going to keep talking about this. It's quite fascinating. Anyway, I'm going to move on. So the key thing here is the thing that identifies you is not you. So you have a social security number or driver's license number, but you're being identified by that thing. Okay, so how does this work in practice? So we have a property called identified by, which links the thing to its identifier. So there'll be a triple Michael Uschold is identified by, and then some instance of just ID, which has a unique text, which is the 9 integers of my social security number. And then the inverse function goes the other way. So that those 9 numbers, those 9 digits, that identifier identifies me. So it points back to me. And going backwards from the identifier to the thing being identified, that is inverse functional, which means there can only be one going in the backwards direction. Because otherwise it's not really identifying anything, or it's identifying more than one thing, which means it's ambiguous and not very helpful. Okay, now notice also that this property identified by, anything at all can have an identifier. So you can't just say, oh, only organizations or only laptops and only products that have serial numbers. No. In principle, almost anything could possibly have an identifier. So we very intentionally leave the domain off. But the range, what does identify a given thing has to be an identifier. Okay. Now this is actually, if you clever people out there might have spotted a bug. I need to fix this. We mistakenly had the identifies property, which is the inverse of identified by, as inverse functional, but that's not correct. It's functional. So that's just a bug that we fixed at one point in time. Okay. So here's just an example. A given person may have different identifiers. These three, for example, and each one has different unique text, which is a string. Now, we talked about a few minutes ago the context. So these are three identifiers, but what does this even mean? What's the context here for this identifier? So there's different ways to do that context. One way is to create a subclass of gist ID and say, this is my driver's license ID, or this is my social security number, or this is something else. But an alternative way, which has there's pros and cons to anything. But the way I'm going to show you right now, we say this identifier is a direct instance of the class gist ID. And here's its text, which is the main part of an identifier. But we're saying we're going to create a category called ID type and then have instances of it. And that's what tells you the context. So there could be another identifier which has exactly the same string, T167000185, but it's not a driver's license. It's maybe a tax ID. A tax ID. Why is this? I'm wondering why this isn't my slide. I'm wondering if there's a bug or if I just understand it. I'm wondering why there's two identifiers that are driver's license type when they look quite different from each other. But anyway, let's move over there. So that's one way to specify the context. So is it a social security number? Is it a tax ID? Is it an organization ID? What is it? You can indicate that by the driver's license. And to ensure that if you use just identified by, then semantically it means that any given identifier can only identify one thing. But the identifier will be unique because of this ID type. But to guarantee functionality, going the other way to say a given thing is only identified by one identifier in one context, then I haven't figured out a good way to do that. So probably have to use shackle. Okay, so that's quite a lot going on with identifiers. Identifiers is one of these things that I think of as advanced common sense. On the one hand, it seems like, oh, that's kind of easy. But on the other hand, once you get into it, it's like, oh my goodness, there's more going on here. Fractions are a bit like that. Try to learn fractions. It's like, oh yeah, that's easy, but that's not. It always confuses people. Okay, so advanced common sense, there's lots of that around. All right, let's move on to something quite different. Temporal relations. So let's just consider following situations or relationships. A person can be employed by an organization, some employer. A business maybe has a business address. A manager supervises some member of staff, which is fine. So we can just model these things as ordinary properties and create triples, saying Michael Uschold is employed by Semantic Arts. That's great. Or Semantic Arts has business address, blah, 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 Fort Collins, Colorado, etc. But what happens if you change your job, change your boss, or change your address? So in fact, Semantic Arts did just move within the past several months. So now we have a new address. Now, if you don't care about old addresses, and you only care about the new address, then you can just change the triple and you're off to the races. But what if you need to track that information? That's where the idea of a temporal relation comes in. And again, there's a whole hour-long lecture on this, and we're just going to pick through a handful of the key slides. So what the fact of the matter is, some relationships hold for a period of time. So I was employed at Boeing, say, from February 08 through September 09. Oh, no. Yeah, that's right. Anyways, some organization or a business has an address, so this has some established location from one date through another date, or maybe I was managed by someone from 1984 through 1990. So these are statements of fact, but I'm not going to forever be employed by the same person. These days, people jump jobs every year or two or three sometimes. So how do you manage that? Now, if I'll gave you the way to say, here, this timestamp, this triple has a timestamp, then you can do that. But we don't have a timestamping in all. So we developed something else. So again, we talked, so how would we represent, let's just take the supervisor's relationship. Here I can just say Jill supervises Joseph. great. That's one option. So just to have an ordinary property called supervises, and this is the definition of the property. It has a domain of a person. So this, depending on the subject, has to be a person. The range has to be person, and it just relates an individual to another individual that they are supervising. So this is a definition. Maybe you have an inverse relationship called supervised by. Links to people, an ordinary triple with subject, property, and object. So this is how you can represent something without, if you don't care about time. But what if you do care about time? Well, now you can create a class which you might call supervision. And it's like, what is supervision? It's a supervisor's relation that takes place over a period of time. So Dave McComb has been my supervisor, if you like, my boss, for 11 years and change. So we have a class in GIST called Temporal Relation. And if you're going to have a particular relationship in mind, which in all would be a property, say, so if you have this thing, if you have this logically or in fact a property called supervisors, and you want to model that a relationship between two people holding for a period of time, you can create a subclass of temporal relation. In this case, we'll call it supervision. And there's two things that it links out to: the supervision, the person who's doing the supervision, so supervision by this person, and who's being supervised with supervision of this person. Now the temporal relation also, the temporal relation itself has a start and an end time, which would be inherited. So this is a subclass of temporal relation, which has these properties about being who's supervising and who's supervised. But the temporal relation itself has properties about starting and ending. So that's how you can represent this information. And in GIST, we have a property called connected to. So these special properties that point to the subject of the triple and the object of the triple, you can create them with special names, which I've done in this case. Okay. So this is what I said a moment ago. The start and end times are inherited from the temporal relation class. And here's now an example. So this is a supervision, an instance of the class of supervision, which means a particular individual was supervising another particular individual over a particular period of time. So in this case, the start would be 27th of April, 1984, and the end would be 21st of July, 1990. So this is how temporal relation works. We've used this a lot over the years in a lot of our client engagements. So the definition of temporal relation is a relationship existing for a period of time. It must be connected to a minimum of two things, which is going to correspond to the subject of the triple for the binary relationship and the object of the triple. So that's temporal relation has, and now again, this, I need to update the slide. We now use different properties. We don't have time instant anymore. Now what's interesting here is doesn't have to be either or. You can start off by just saying, you know, I only care about supervises. That's great. Put this information there. And if at some point things evolve to be where, oh, actually I need to record this business of time, then you can say, then you can have that thing, but you could infer on the basis of this here, on the basis of this here being true, this supervision was somebody supervised somebody else over this time period. You can infer that there's a triple supervises, right? And then you can have a property that says, you know, most currently supervising or things like that. So you can kind of have both for a period of time. Okay, now I said I've used this a number of times with a number of clients. Most of the client stuff we can't talk about, but International Monetary Fund is an NGO. It's not a corporation that cares about IP and things like that so much. So here's just a few small examples. Expertise. They need to know who's an expert in coal, you know, mining or gold mining in Africa. And, you know, maybe you had a lot of expertise for a period of time and then you cease to be the expert because the whole field changes so much. So they need to track who had expertise in a given area for a period of time, or who was a member of the IMF. Membership is quite important. But you can be a member for a period of time and then you're not a member anymore. Or you can participate on a committee for a period of time. I was on this committee for 7 months in 2021, but I'm not participating in it anymore. So these are real examples that showed up in that particular engagement. Okay, looking at the time, we still got some time left. That's good. So addresses. So we're still on content. We talked about documents, media. IDs is an example of content, and now we're going to talk about addresses. Addresses are very complicated. You think it's straightforward, but it's not at all. So we often think of an address as a place, say a building, but really we would say this is a building, and the building is what we call, from last time on June 2nd, the previous just council, a physical identifiable item is attached to land. That's what a building is. Buildings typically, but not everyone. Your outbuilding in your backyard where you store your lawnmower and your skis and your bicycles doesn't have an address. So not all buildings have addresses, but many of them do. So really, what is an address then? It's content which tells you how to get something to somewhere, right? And sometimes the somewhere isn't even a fixed place, like shipping. If you're in the Navy, you have a shipping address. You send it to the address, but the ship could be in Timbuktu, or it could be in San Diego, or it could be in anywhere. So it's not even a place per se. It's on that ship, but that ship could be anywhere on the planet, exposed except for the Sahara Desert. All right, so it's a package, and for packages, sending things through the post, it's just tells you how to get somewhere. It's a tiny little piece of content, so we can send stuff to people and organizations. So what kind of addresses are there in GIST? We have electronic message address. So for example, your email address, postal addresses, which is the most common address we find. Telephone number is not obviously an address, in everyday parlance, but when you think about it ontologically, you realize, well, actually it's a way to communicate, it's a way to get information to this person, a text message or a phone call. So it is really an address. There's relationships to addresses, which we talked about a few minutes ago. So semantic arts was at one address for goodness knows several years anyway, 10 years since I joined the company, and we just moved within the last year. So you could say a person resides at an address or a business resides at an address. That's a relationship. And again, this is the example we saw a few minutes ago. You could have an established location, which is a temporal relation. So the person resided at a place for a given period of time.
Another question on that, Michael.
Yep, go ahead.
Isn't an address an ID?
What is it identifying?
It's identifying whatever the address is identifying.
Well, let's say.
I mean, a phone number is an ID. It's unique. An address is unique too.
Well, there's the caller ID, not like the number itself.
Mm.
That's an interesting question. In some contexts, people do this. You could use, but how about, so my sister lives with her husband, and they have each a cell phone, and then they have a house phone. So who does that landline identify?
Yeah, it identifies a family or whatever. I mean, you're right. It's ambiguous. It's ambiguous either way, by the way. It's ambiguous with this ontology. It's ambiguous with an ID ontology.
It's an interesting question. Is a phone number is an address and a different? I'm inclined to say not, because a person can have. You can have a country cottage, up in the mountains or on the beach, and that's your address.
So it's the bidirectionality that's different here, because obviously a person can have multiple addresses, a person can have multiple phones, a person cannot have multiple social security numbers. So
Actually,
maybe
I
maybe
would
that's
say,
what it is.
I would say the relationship, I want to not go on to this too much longer because it's a complex thing. You raised a good question. But as far as an address identifying a person, suppose you own the property and then you sell it to somebody. So that address no longer identifies you.
No.
So
Yep.
was it ever an identifier in the first place?
Yeah, and yet your phone number travels with you. So I mean, yeah, I can see how
Now it does.
murky.
I've changed
Now
phone
it
numbers
does,
3
but that's-
times.
Oh yeah. You're right. You're absolutely right. I mean, but now even the zip code no longer. Actually, I mean, not the zip code. The area code is no longer identifying where you are anymore. Used to be.
It's a good question. I'm going to move on. Thank you for asking it. Now, another thing that's important is to state how you wish to be communicated with. So a person can say, I want you to call me on the phone, or I want you to text me rather than call. But for business purposes, like maybe for this project, I want you to call me on this number, but for this other project with this other client, I want you to call me at this number. So this notion of a communication preference is actually pretty complicated. So you could say, for this context, over this time period, I want you to reach me this way. So that's another thing you can do with communication preferences and addresses. Right. Okay, summary. So we have addresses as first-class objects in JISC. Now, I didn't emphasize that when I started this conversation, but people typically just have addresses as text in a field, right? So in OWL, text isn't a thing per se that you can say things about. We have addresses as first-class objects that have unique text, but they are not text inherently. There's a rich set of relationships between people, organizations, and addresses that cover everything from occupancy to communication preferences. We designed the approach that we use to be future-proof, although there's always interesting questions about identifiers and those relationships. And again, there is a whole video that goes into this in grand and glorious detail that was given by Dave McComb at some point in time, probably within the last year or so. Still got a few minutes left. That's good. I'm just going to keep going. Intellectual property. This is an interesting one. JISC has about a dozen or 20 top-level classes, and everything is a subclass of it. And whenever we go into a client engagement, we always try to hook whatever shows up in a given enterprise. Nothing's new under the sun is our principle, and of course there are exceptions to every rule. And so whenever we go into a client, we all the concepts, whatever they are in that business, we hook it up to something and just. But every so often something shows up and you say, "Oh, what is this darn thing?" And that occurred to us when we did work with a major company that has hundreds of brands. It's they just have brands, and more brands. And we wondered what in blazes a brand was. So we created a new orphan property. Orphan just means it's not a subclass of anything. And then we thought about that for a long time. Eventually, just some years later, we created something called intellectual property. So what is intellectual property? It's a work, and it includes brand. Brand would be one example. Although brand is a highly ambiguous concept that I'm not going to get into at the moment. But what is intellectual property? We can understand that a little bit easier than the notion of brand. It's a work, an invention, or a concept, independent of how it's expressed. So the book, Mark Twain's, well, not Mark Twain, but the book, pick your favorite book. My brain's going blank. Moby Dick, say. Take that book. It can come out in different editions. It can come out in different publications, hardcover, softcover. Could be an audio book, could be a movie. But this notion of a work that supersedes all that. And again, this is laid out in detail by people who worry about these things. This is a broad category that we don't specify a lot of detail underneath that's left. If intellectual property is a big part of your company, then our experts would go in there. and model that out, but it wouldn't go into just proper unless it was something that showed up over and over again for lots of organizations. So these are some examples. Coca-Cola, Mickey Mouse, a patent on, a page algorithm, and we actually put computer programs as intellectual property. So if the actual program, like the Word software or any software, SAP, that's really intellectual property. Okay, and it's always content. Well, it's almost always expressed at. I think it is always expressed at or embodied in some just content. You can't say I wrote a book and it's all in my head. Right? You have to write it down somehow, some way, or have a video recording of it, or make a tape recording. Okay. I guess this is gonna be our last thing. Collections and categories. This is interesting. There's lots of different ways to put things into buckets of one sort or the other. And there's 3 ways we can do that in GIST. And to some extent, this is not just specific. So one case we can say, we can use the notion of a class, a subclass. It's just a class. So for example, the class person, we could say, well, person is a bucket. What kind of a thing? So you have a laptop or a microphone or a pen or a pencil or a brand. What kind of thing is it? What category of thing is it? Oh, it's not a person, but so then you can just bundle things into categories by creating classes. And then you put something into the category by using RDF type. Another thing you can do is create a collection. So for example, maybe a deck of cards or a jury. So for example, O.J. Simpson had a jury. So it's really a collection of 12 people. Those 12 people are kind of functionally related to each other. They have a joint purpose. So you wouldn't really create a class and say this jury, because it makes more sense to create a collection. So this is an alternate way of doing something. So you create something called jury. It's a special kind of grouping of individuals. So we have something called GIST collection. And then, so if you're going to create an instance of different juries, then you would create a subclass of GIST collection called jury. And then individual juries would be instances of that class. And then those individual juries would be linked to their members of the jury using not the property RDF type. So RDF type puts something into a bucket if the bucket is a class. If the bucket is a collection, then you use is member of to put things into buckets.
Michael, you had a quick question in the chat. Is that supposed to be the difference that they have a purpose?
It's a bit fluffy. That I kind of use that myself. If the members of the collection are somehow functionally connected in some way, then that's a good indicator that calling it a collection is a good idea. These things are not baked into the all language. They're more tradition and conventions of how we model things. And just we generally model things as classes if it corresponds to a kind of a thing. So a jury is a kind of a thing, so that's why a jury is a class. But the O.J. Simpson's jury is not a kind of thing; it's a specific thing. Go ahead.
Yeah. So I think this is tricky too, right? One of the ways I've gone is that I think of classes as intentional and collections as extensional. I was wondering if that's how you respond to that.
That's an interesting question. I mean, that's an interesting way to look at it. I wouldn't say it's wrong. You can create extensional classes in GIST, which is enumeration. So for example, you can create a class called United States State, right? And you can define it to be the set of exactly 50 things, or 50 states. And that's genuinely a class, and each member, and the notion of a US state is a kind of a thing. So that would be collection is proper, even though it's extensional. So your intentional versus extensional probably holds a lot of the time, but not every single time. And I'm just going to wrap up because we just got 2 minutes left. The third way you can put things into buckets is by essentially putting things into topically categorizing things, like you have a Flickr tag or these days Instagram or whatever. So for example, if you have a tag called winter, so things that are related to the subject of winter somehow, maybe there's a photograph of a blizzard, or maybe there's a book called Winter of Discontent, and these things are all have the tag winter. Maybe a snowman is also JPEG. So one or two, let's see. I think I'm going to have to pause here. It's 1 minute before. So what I'll do is I'll start next. Let's see how much more is left here. You know, there's probably enough to have another session next time. Yeah, there's enough material to have another session. So I think we should have a part 3. That's my feeling. Any questions before we wrap up? Final comments, questions? Nope. Well, thank you, everyone. Appreciate your participation, and we'll see you on next month.
Yep. I
Yep.
will get this presentation posted and we'll plan part 3 for next month.
Excellent. Thank you.
Thank you very
Michael.
much.
Hey, you're welcome.
Fantastic. I hope you'll be able to finish up the collections and categories next time too. Just maybe wrap up what you didn't get to say, because it's very of great use to me.
Yes, I will do that. I'll start with the slide that you're currently seeing. I'll review that one, and then I'll get into the details that followed.
Thank
Great.
you.
That's where I'll start. Okay, very good. Thank you, everyone.
Thanks all.
Bye-bye.